uh, dear student, here I want to solve a one-dimensional heat conduction problem in the MATLAB. Prior to proceeding with the MATLAB, let me discuss some basic things involved in the one-dimensional heat conduction problem. Then I'll be executing some sample problem in the Excel so that you can understand the logic behind the solving the problem in the MATLAB. For that, let me take a rod first. Okay, let me take a one-dimensional rod here, where one one end is exposed to the insulation. Okay, insulation means there is no heat flux. Okay, I can denote that by a mathematical expression rho T by rho x equal to 0. The meaning is there is no heat is flowing from this place to this place. That is the mathematical expression. There is no change in the temperature gradient with respect to x at this position. And this when time equal to zero, I'm going to divide this equation into a small parts. I technically will be calling as the nodes. When time equal to zero, the entire rod is exposed to the 20 degree Celsius. Okay, and when time equal to zero, that is the after the time equal to zero, the edge node. Okay, this will be exposed to the temperature of 300 degrees Celsius. So this node I'll be calling it as 300 degrees Celsius. So let me call this node number 5. Let me have 1, 2, 3, 4. Okay, those node let me have. Only got this one. Okay, and this is my node number 5. And now what I'm expected is I want to find the temperature at node 1, 2, 3, and 4 at different time. Let me take when time equal to 0. This is 20 degrees Celsius. This is 20 degrees Celsius. It is 20 degrees Celsius. Let me take small random value here when time equal to 0. Then hereafter I want to find a temperature profile from every 0.1 second or 0.01 second. Okay, and let me take this distance between each node del x, and distance the space between the two time is del t. Okay, and similarly I have to extend till whatever time demanded by the problem giver. Okay, let me give time equal to infinite something else. Okay, so I need to find the temperature at different time at different nodes. I have the governing equation, that is the law which follows, can be described by dou t by dou t alpha dou square t by dou x square. Actually, it is in the continuous domain. I want to discretize as I have done in discretization. Uh, it is a continuous thing. I discretize into the uh, 1, 2, 3, 4, 5, 5 space. Okay. So I want to discretize. There are multiple ways to discretize. Here I'm going to take a simple method. Since it is only for the first year graduates, I'm going to discretize by implicit method. Sorry, explicit method. Okay. Here I'm going to take explicit method. So this is the governing equation, and this equation is discretized forward in time. So here Ti n plus 1. So future minus the current time divided by del T alpha. Then it is a central difference method. Okay, and Ti plus 1 at n. So this is what I'm looking for. I want to find the time at n plus 1 using the current value. That's what n means. Okay, it is a by central difference method. It is a forward difference method in the time domain, central difference in the space domain. So we can apply different kind of discretization both in the time as well as the space domain. Okay, and that's what I've given. And this equation is simplified here as Ti n plus 1 equal to n. So m is nothing but I just combined all the constant into the one category. So alpha del t is the space in the time domain, del x is the space in the distance or space domain. Okay, and I'll be rewriting this equation in the plane. Okay, and look at here. I want to find Ti. I want to find the temperature at the ith node at n plus 1 time. That means I want to suppose I know this temperature. I want to find at the n plus, that is the means. Okay, n is the n plus 1. So what I need is to find that I must have the Ti, must eliminate Ti n. So Ti n. So this is my, suppose I'm looking for the node at 2. To find this space, I must take this value plus m multiplied by Ti plus 1. Okay, Ti plus 1 at the nth node plus Ti minus 1 n minus 2 times of Ti n. So what I need is to find this space, I must have the value, will be right here, Ti at 0.1 second at node 2 will be equal to this 20 plus m value. Let me do it in the Excel itself, m, and Ti, yeah, Ti plus 1, sorry, okay, I plus 1. This is the I plus 1. This is the I plus 1 means 3. So 20 uh, plus Ti minus 1. This is the Ti minus 1 is the 2 minus 1. This is the T1. So 20 minus 2 times of the same node I'm looking for, but the previous time, 220. So I can calculate T2. Similarly, I can extend to T3, T4. For us in the problem, throughout the entire time domain, at the fifth node, the temperature will be 300. That's what problem mentioned. It is a 300 degrees Celsius. So I need to, no need to worry about to find a fifth node. It is always 300 degrees Celsius. Since this node is exposed to the high temperature, these temperatures need to be calculated at each location. That's what these values will be keep on changing. One difficult part is when I'm going to the node number 1, if I'm going to write here node number 1, let me write here. Let me apply this here for node number 1. So Ti, node number 1 means I will be 1 when n plus 1 equal to uh, T1 n plus m T2 n. Just I'm applying this correlate with here. T naught n minus 2T1 n. We look at this equation. T2 is can be taken from the value nodes of different location, and the T1 also can be taken from the previous one. But we have a node T naught which is beyond this location. Okay. Sorry, it is a. Let me take this node number 1. Okay. Let me take this is the node number 1. Don't cut this node 1. Okay. And node 1. Let me take this is a node 1. This is node 1. So node through 3, sorry, 0 will be located somewhere beyond the my point. This is my node 0, which is hypothetical to me. It may exist, but I don't know what is the value. And also, I'm not interested at all to find the T naught. So I have difficulty. What is the value of T naught? For that, I'm going to use another boundary condition. It is called a Newman boundary condition. There is no heat flux at the beyond this point. Okay. For that, I'm going to apply this equation at the zeroth node. This governing equation. So here I'm going to apply simple difference here. Ti n plus 1 minus Ti, sorry, it is not n plus 1 since I'm focusing on the space domain. Okay, so here should be I plus 1 n I minus 1 divided by 2 del x equal to 0. If we task multiply, this will become 0. So what I will get is ti plus 1 n equal to ti minus 1. This is applicable only this node because at this node only we have this governing equation. Okay, what it means is this value, that is, let me apply it here at zeroth node. Okay, at zero. Here, what it means is at node number 1, this value will become ti minus 1 will become t0 n. Just have, and it's equal to t. I'm looking for the node number 1. Just look at it, t2. So what it means is this T0 can be replaced with a T2. Therefore, at the node number 1, I'm going to use that in the MATLAB code also. So T0 n will be equal to T2 n. This equation can be used to find the temperature at the node 1 in the upcoming process. Okay. Now let me go to the Excel sheet where you can understand things very properly here. Yeah. Have in the Excel sheet I have both uh, explicit and implicit method. I will be showing only the uh, uh, explicit method. This is the governing equation. So here we had it as a Tn, but both are same. Okay. So now what I've done is just look at here. First, I have using del t and alpha and del x. I'm finding what is the m value. Okay. Then I'm checking the stability condition whether it is the stability value whether it comes under the 1/2. So it is 0.1, it is less than 1/2. Okay, so there will be no stability issue here. If you want, I'll tell you stability issue also what stability means. Okay, now, now just look at here. First thing what I'm doing is the similar procedure will be followed in the MATLAB. First, I have taken that when time equal to 0. In the all the nodes like 1, 2, 3, 4, I have initialized with a temperature of 20 degrees Celsius. Okay. Then at node number 5, I have given 300 degrees Celsius. If you look at here, in all the nodes, I have given the 300 degrees Celsius. Just keep it in mind, the MATLAB will be solving different problem, but similar concept. Okay. The moment I have, yeah, the moment I have uh, fed the value for the node 0, next thing is after that, after in the MATLAB, after initializing the first row, I need to repeat I have to for when time equal to 0.1, I need to repeat this formula. Just look at here, this formula for each node. So here. Okay, I need to write the formula. This is what written here. For each cell, I written the formula. So here I'm going to repeat the formula for all nodes from 1 to 4. Done. The same formula will be repeated for the each time domain. Next, I'll be going to the 0.02. So here I need to, I'm going to use the two for loop. One to repeat within the same time domain. In this time domain, I'm going to find what is the temperature at each location. And keep it in mind, when I'm going to find T1, I'll be having the hypothetical node that is a T naught, this T naught. In that case, I can use T2 as my T naught. That is a simple modification I can make in this equation. Okay, and similarly here there's no need of modification here. Okay, then the first I need to find a different location using one for loop. Then I'll be using the second for loop to find till the entire time domain. So I can extend till whatever thing you want. In the Excel, it is very difficult to extend the number of domain, and also somewhat there is a difficulty in the finding location. Okay, now let us calculate in the MATLAB also. Let us do this procedure with a different problem, the higher time domain, the MATLAB. And now I have written entire code in the MATLAB to save the time. I just written entire code. I don't want to read it again. And as I have done the Excel, you can look at here. First, it is my length of my rod. Okay. And next, I have defined alpha value. Then nx is the number of space in the x, that is a space domain, that is spatial points. Okay, number of spatial points. You just look at here. Here I'm able to only show the 5 points. If you look at the Excel, maximum I can visualize the 10 point within a page. So, but if I'm going to increase number of points in the Excel, it is very difficult for me to view and execute the formula. That's what I went to the MATLAB. Here in the MATLAB, I have a number of points as a 50. Then number of time steps. Okay, and here I have done maximum of, just look at here, even to 70, even I have extended till 93. It takes lot of space in the Excel. So it is very hard for us to execute in the Excel where we have more number of times domain. Okay, and here it is nt equal to 1000. I have to. Now I want to find what is dx, as we have done it in the or del x in the manual calculation. And I want next I want to find the del t. Okay, for that I written the code here. Nt, so dx equal to L, that is total length, divided by number of spatial step points minus 1. So I'll be getting the what is the dx will be. Similarly, dt also can be calculated. It is not calculated, it is given as 0.01. So I can extend till the 1000. So here first step I have calculated dx and I'm taking some random array of dt. Then I'm creating a space of x equal to line space. I'm going to execute this code for you so that you can understand here. This is going to create me length is, let me take it is a 1, and nx is nothing but it took us 50. Sorry, let me copy this code again. See, let's see. Okay, my length will be equal to, it is defined over there, 1, and my nx will be my 50 number of points in the space here. Okay, so if I'm going to execute that, just look at here, generate from 0 to 1 of 50 points. Just look at here, it is a 1 into 50. Then I'm going to define what is my T max. T max here it is calculated by dt multiplied by nt. So I want to what is the maximum time. This will be my, uh, you know that my, let me, no need to do that. Let me do it one by one. dt is, we know that it is 0.01, and my nt is number of times still, it is a 1000. So what I'm going to get is, I'm going to extend my time till 10 seconds or 10 minutes, depends on the what dt I took. Here I'm not defining what is the unit of dt. Okay, then similarly I'm creating time line space also. Same as what I went in space, starting from 0 to 10 seconds or 10 minutes, and with a number of points of 1000. Next, once I have done my basic definition, I'll go to the stability condition, which I told you. I want to check R equal to alpha multiplied by dt divided by dx squared. If it is less than equal to 0.5, then will throw me a statement called stability condition is not met, reduce the dt or increase the dx. That's what I told you. In the explicit method, I can't choose the del x and del t independently. Both are dependent. Either to increase the stability, I need to either reduce the dt or I have to increase the dx. Okay. Once I have done those the basic things, then I'll go to the one by one. The first code, I want the initial temperature. So as I told, I'm going to define initial temperature of 20. This will be generating once of nx equal to 1. I'll show you here. I'll put some random value here. This command will create, let me take nx equal to, let me take 5. Okay, random value here. Just look at here. You will create a vector of 1, 1, 1. So if I'm going to multiply by 20, again, if you want to just look at here, uh, 20 multiplied by 5. It will create 2020. So I'm just initializing as I have done in the Excel. Just look at here, initialize the temperature of rod as 2020 in all spaces, nx, in all the spatial points. Then U1. So now just look at here. I'm going to at the point number one. I know the boundary condition is given in the our manual. It is 100. Okay, I'm not showing the manual here. 100 degrees Celsius. So I'm going to locate U1. That is the at point number one. This point is defined as reverse. I have done. I'll be creating all the things. Okay, the rod, the rod. Here it is 100 degrees Celsius. That's what I'm defining here. Okay, the boundary condition at x equal to 0. Then a storage of solution. In the MATLAB, I need to initialize my entire array. So I'm going to give here U. So what I'm doing here is that I'm going to create a array uh, here x 100 times. Here I'm going to create from 1, 2, 3 to 50. And here time from 0 to 0 point, I think it is 0 point, 0 point 1 we took, I think so. Yeah, let me check it. Yeah, 0.01. So from 0.01, 0.02 to till 10 second minutes. Okay, I'm going to initialize the array. Each point except the first row. Just look at here. Okay, first I'm initializing entire thing the 0. Entire all the points. I have not yet calculated all the points as 0 till the end. Okay, I'm just writing randomly. Pardon me. It may be not visible clearly. Yeah. Once I done these steps and just even I can execute this code, okay, with a small number so that you can imagine what is this, okay, and 3 comma 2, okay. Let me run this. Okay, it will be creating 3 cross 2 of matrix 0 0. Then once I created, what next step is in the it is all the row of first column, okay. So this is the all the row of first column will be given as the U. Sorry, all the row of the first column will be this value will be taken. So this initial condition will be taken with the my 20, where the this point 20, 20, 20, and this will be my 100 degrees Celsius. That's what we are doing here. So here I define small u, then I define capital U. Once I define all the capital as 0, then I first row. Okay, first row. Okay, I have of u. Then I'm going to do my calculation. Just here I have written the two for loop. First, starting from sorry, here is a I think it is a 100 here. Node one is maintain 100 degrees Celsius. The another node is the it is the here it is the insulator dou T by dou x. Okay, reversal of what I explained manually the previous step. So here I have to start from the node 2 because all the node 1. Okay, sorry, here is the, all the node 1 is here. What happened is I defined this value as 200. Okay, here we no need to worry about 0 here. Here all the columns are defined with a 100 degrees Celsius. Okay, and all the these values are given to the my matrix here. Okay, then I'm from second points. Okay, from since node number 1 is my boundary condition, all are filled with 100. Okay, I'll be executing one by one. Just look at here so that I can understand the code. So there will be no confusion at all. Yeah, I'm executing these values. Then once I execute it here, then I'll be executing this one. Just look at here, executing, yes, selecting only. Okay, what I'm defining is U. I'm defining. What is U? My U is nothing but, just look at here, U, what is a 100, 20, 20, 20, it is defined. Okay, just look at here. Now I'm going to execute this one, run selection. Okay, just look at here, all the columns. Okay, are it is created one of, it is the we created 50 space point and no of one columns. Okay, it is number of rows, it is number of columns. So here I have only one column. Here, only one columns here. Next thing is, let me clear this. Okay, CLC. Then once I have done that, then I'll be executing this one. Okay, I will be executing this evaluate selection. So now I'll be defining U. Yeah, just look at here. 0, 0 matrix are created with the size of nx, nt. Now just look at here. I'm going to execute this. Sorry, CLC will be execute this code. Okay, I'll be doing one by one. Just now look at here. Now my U will be revised to one. Just look at here what I've done. Colon. It is all the rows of first column. Just look at here. It is very difficult to look at here. Let me click on here and just look at here. The first column are filled with 100. First one is 100, then 20, 20, 20, 20, 20. Till, just look at here, till 50 space. So here I just explained the Excel. I have done it in inverse manner. What happened is here is how did I define is X is here and time is here. So here time is 0 to 10 second, and here X is 0 point. Let me take what is it? Del X I took. Okay, and dx is, let me check what the dx it is calculated. Yeah, 0.204. Okay, so from 0.004 to till 50 points. That is a 1 meter. So here the time. In the Excel I discuss in different way. It is the inverse in the MATLAB code. Okay, that's what I'm having here. In the you can check by one. You can understand largely behind each and everything. Okay, the 50 space in the all the columns. Okay, 50 rows and 1,000 columns. So first things are filled here. Next, what I'm going to do is, next I'm going to execute uh, here. Let me go to here. And if I'm going to execute this code, first I'm going to what I'll be doing is first I'll be calculating from for I as 2 to nx minus 1. Okay, so from here I'm going to calculate my. I'll be explain the pain. Uh, I'll be rewriting again x and time. Okay, time 0, 0.01, 0.02 till I'm going to fill it with the till it is a 10. Okay, and x 0. Yeah, let me put node 1 instead of putting node 1, 2, 3, 4 till 50. And we know that when time equals to 0, node 1 will be exposed to the 100 and all the points will be 20, 20, 20 till here it is a 20. Then what this formula tells me here is start from I equal to first I'm executing, I'm going to complete this entire column. So don't start here. That's what I'm going to start here from 2. Okay, here I'm going to calculate using this formula till the entire 50 nodes. This I'm going to calculate. That's what the code implies. They goes from 2 to nx minus 1. So till the end. Okay, here I'm going to calculate. But just look at here, I'm not calculating at the fifth node because at the fifth node, the boundary condition is here is the dou t by dou x equal to 0. So here I have to apply different thing. That's what I'm extending till nx minus 1. So this formula will be repeated. Once it is repeated, this for loop, once it is completed, this for loop will end. Then I'll be defining Newman boundary condition. As I said, this point temperature, it is a T of 50 to calculate T of 50. I have defined here. It is a u of nx minus 1. It is equal to setting the flux derivative to 0. So I'm going to define the value here. U of nx at the 50th node will be nx minus 1. And here, then this value will be stored in the all the rows of n plus 1. What is the n? N is at first point 1. So this will be repeated for all the points. Okay. Now I'll be executing entire code. Okay. Select all. Yeah, this will be clear this. Okay, and if I'm going to run the code, the big plot will be created. So the plotting point is self-explanatory. You can understand. First, I'm plotting the graph. This command, will this command will create a plot uh, in the 3D mesh. Okay, so I'm going to plot x, t, and u. So at different time, at different location, what is the temperature? So I just labeled them accordingly. So it is self understood. And similarly, I want to plot at any particular, I want to plot 2D plot here. I want to plot temperature with any position at the final time. That's what at final time I have to NT and plot the graph. That's what the plot number. Okay. It is a temperature distribution along the rod when time equal to 10 seconds. So if you look at here, node 0, the temperature drops from 0 to around 29 at the final time. This is a temperature distribution along the rod, which is calculated. Okay, so entire length is 1 meter. And this next part is I want to temperature is a time. Okay, I want to at the mid position. So, okay, at the mid. Okay, that is at the 0.5 location. That's what I code written here. I extract the data according to that. So just look at the code. Okay, and that's what I'm having the plot. Now what I'm observing is when time equal to 0 at the center, as we insulate 0 degrees Celsius, as time progresses, the temperature rises gradually and reaches the temperature of it is the around 47 something. What is the advantage of MATLAB is just look at here, the temperature is not yet reached the saturated condition. So for that, what I can do is so I can increase the time domain here. Just look at here, I can change the number of time domain here and put 1000 number of time steps. Okay, and let me run the code. So the entire code should be run, and just look at here. The last plot, the temperature almost approaches. Sorry, yeah, this plot almost is near to the saturation time step. Okay, and still, if you can increase the, I'll be closing all the graphs so that it will not be confusing you. Okay, I'll be closing all the graph. That is the advantage of using the programming language. If you are going to do it in Excel, it is very hard for you to calculate. Okay, Let me put that. Let me add another zero. But it is very tough in the Excel to repeat it for the distance of times. Okay, you will run the code. This takes only few seconds, not even few seconds, and the code will be displayed. Just look at here. Almost all the nodes are at temperature of 100 degrees Celsius. This is what? At what time we just look at here? Almost at 120 times seconds. Okay, this is at 120 to 150 seconds. All the rods have the uniform temperature of 100 degrees Celsius. That's what happened when I'm going to expose the rod to the to heat of 300 degrees Celsius or 100 degrees Celsius. After some infinite time, the entire rod will be having the same temperature. That's what the plot shows you. Okay, and you can look at here how the temperature ranges at different location when time equal to 1,000 seconds. Okay, so this I done it only for the 1,000 seconds. Yeah, there may be a one doubt while applying the name and boundary conditions. Just look at here. Here, u nx equal to u nx minus 1. It is different from what I have defined here. Here, what I defined here is simplest way. If you write on the plane, uh, uh, T50 at the 50th location is equal to T49. That is the meaning of here. Just look at here, the MATLAB. That's what nx and nx minus 1. Okay. But what I have proved you, what I have shown to you is T49 equal to T51. That is the meaning. Okay. But why it happened here is in the MATLAB code to simplify the entire process. What I've done is I have not applied the central difference. I applied the simple backward difference. That is dou t by dou x. I discretize as uh, ti minus ti minus 1 divided by del x. If apply this boundary condition, ti will be become ti minus 1. That is the only difference in the code because I want to simplify the code for the first year undergraduate level. Thank you for watching the video.